Hey folks, I want to show you a kind of a real world example of what people try to do in science and engineering and mathematics. We have a whole bunch of points being plotted right here, and we have a function that's fitting it really close. It looks like the function needs to be shifted down a little bit. These are kind of funky points, aren't they? Just so that you believe me that that's really what they're doing, I wanted to show you right here are the points, right? So if I hold my mouse down on that red dot, come on. Okay, well I can turn them off. I want to change, oh there we go. I want to change the way the points look. So, usually we put solid dots. I don't, whoever made this thought it'd be looking kind of cool to have open circles like that. But these are just a bunch of points, and then whoever made this fit a function to it. But man, look how complicated that function is. Sine, exponential function, or I'm not even sure what that is. Arctangent, I know what arctangent is. So when I look over at my notes, I want you to set up your notes right now. We're not going to be talking about anything that complicated. Look at our expressions here. These aren't really functions, they're not set equal to like y equals or anything like that, or f of x equals. They're just expressions over here. As you're copying this stuff down, just kind of peek over here, okay? What we're responsible for doing is identifying if it's a polynomial or not. And then we're going to figure out what the degree is, and we're going to learn a few vocabulary words, okay? That's it. This guy over here, it's not as complicated as this. Notice it's a function, f of x equals, and I can turn it on and off. It goes, let me zoom out a little bit. That function is the one that's being graphed over there, right? So, this is, I hope, going to be really straightforward, all right? If I look at this expression over here, we learned that when you have a variable in the denominator, you could move it up to the numerator, and it would be a negative exponent, right? So if you move it to the other location, it changes the sign on the exponent, okay? So there's two terms here. These things are called terms. Here's a term, right? So there's two terms, and because this one has a negative exponent, no good, okay? So I'm gonna use that phrase over and over again here. It is not a polynomial, not a polynomial. Cannot have negative exponents, okay? So let's put that down over here. No negative exponents. Okay, now let's go on and look at this one. Well, this one, shoot, doesn't even really have a variable, does it? But what you could think about is there isn't, but you could think about it as there's an x here to the 0 power, right? Remember how a 0 power gives you 1? So this is actually a polynomial because you can have 0 for the exponent. So 0 is okay for an exponent. 0, okay, exponent. Okay, I know that's not great English, but it's early in the morning. All right, so this one is a yes. Shoot, I don't know if I put a no anywhere. I guess I did the no good, right? So no good, not a polynomial, no unpolynomial, okay? Oh, by the way, poly means many, right? So like a polygon has many sides. Polynomial means it has potentially many terms. It doesn't actually have to have a lot of terms. It could, like this one has 2 terms, this only has 1 term. So let's put that down. This one had 1 term. Remember that phrase right there, 2 terms, 1 term. Okay, we're going to get down here for this vocabulary in just a second, all right? Oh, well, look at this one. This one doesn't even have an x. Does it matter what letter we're using? Doesn't matter what letter. Okay, so any letter for a base, any letter for the base, the base is, what you're erasing, what you're putting the exponent on. So any letter for the base, let's put that down, is fine. Okay, so variables are good. It doesn't even have to have a variable, right? Like with this one didn't have a variable, you could think about it as x to the 0, so 21 was a polynomial. This one is a polynomial because, see, it's a 4 up there. It's a 2 up there. So let's put down Uh, non-negative integers. Woo, that sounds complicated. How about we just put whole numbers? Because we already said 0 is good. So whole numbers, I don't think whole numbers really include 0, but we said 0 is fine. Whole numbers, yes. Oh, let's put this while we're putting it down. Fractions, no. You can't have fractions. If something's going to be a polynomial, fractions, no good. All right, so when do we have a fraction? That'd be like a square root sign, right? So let's maybe put that down. Like a square root sign, that's a definite giveaway that it's not a polynomial. Okay, so that'd be like an x to the 1/2 power. That's no good. All right, so this was yes, and it has 3 terms. 3 terms. Remember, terms are like 1, 2, 3. They're separated by pluses and minuses. So I hope I'm making that clear. The next thing, let's look down here a little bit lower, okay? We've got another, ooh, wait, uh-oh. There's a variable in the exponent. No good. You cannot have variables in the exponent. No good. All right, so let's add that. No variables in the exponent. No variables in exponents. Okay, exponent location. Variables belong in the base. See, this is the base right here. Let's make a little note of that. That's the base, right? The base is c in this case, and then the exponent is a 4, a 2, and I guess you could think about it as like c to the 0, but you don't have to really worry about that over there. All right, so what did we have? We had 1 that was a yes, or like number 2 is a yes, and number 3 is a yes, and 1 and 4 were no's. I didn't see one that is an example of a fractional exponent, so let's put one down. Let's say you had like 5x to the 2/3 power. This would be no good because of the fraction. Okay, no good, not a polynomial. So these two are not a polynomial, and problem number 1 was a polynomial. Okay, so that's how the assignment starts today. You have to just identify if it's a polynomial or not, and then it's going to say what's the degree of the polynomial. So let's go back to this one right here. The degree is 0. Degree equals 0. On this one, the degree is 4. Degree equals 4. So what is the degree? It's, I would say, the highest power. So let's put down that for now. It's the highest power. Gotta spell it right. Highest power. Highest exponent. How about that? We instead of using the word power, it's the highest exponent. Now, it does get a little tricky if you had like 2 variables. Let's say you had like 5x squared y, because there's a 2 here and there's a 1 there. The degree equals 3. Okay, you have to add the exponents if you had more than 1 variable to figure out what the degree is. All right, now this part's easy. Mono means 1. Bi means 2. Tri means 3. So this is how many terms they have, the number of terms, and they give them a fancy word like monomial or binomial, the number of terms. Okay, so let's go back. On this one, this was a monomial. Oh, let's put that right out here. Monomial. And then this one right here was a trinomial. Trinomial. I guess this one has 2 terms, but it's not a polynomial, so I'm not going to call it a binomial. If they ask, you know, if it's a function or if it's a polynomial and it's a no, I don't think they ask if it's, you know, binomial or trinomial, because these terms usually apply to a polynomial. Hope that's clear enough. That's what you need to understand for today. Let me just kind of review up here. It says I can identify what a polynomial is. I know what the degree of the polynomial is. Ooh, I can add or subtract 2 polynomials. That just comes down to like terms. You can only add or subtract like terms, right? So look for those like terms, and you can use some polynomial vocabulary. So the vocabulary that we're responsible for is right here, okay? In video 2, I'm going to do some homework problems with you. So if this wasn't enough information to knock out the homework, check out video 2. Thanks for watching, everybody.